All right, guys, again, hello. I'm gonna teach you chemical equations this time. All right, so again, pen and paper, and we can get those chemical equations in just because they're a little bit different than formulas, and I don't want to make the video too long because, well, I wouldn't want to watch it, to be honest with you, so why do I expect you to? We're going to start, again, small, and then go larger, okay? So first example is going to be carbon plus oxygen yields to carbon dioxide. Okay? Those of you who like my stories, I taught my child about carbon dioxide and photosynthesis recently, so trying my best to get him all the information he needs. Now, let's talk about some vocabulary, okay? So there are two sides to this chemical equation. We have a left side and a right side. Of course, we don't call them that in science. We call them reactants and your product, okay? And way back in about September, October, I talked to you guys about baking a cake, okay? So you have your ingredients. This is going to be your ingredients. Then you have your product. This is going to be your product, right? And just to kind of refresh your memory, I'm going to write those words on the top, and then we're going to talk about what the arrow means again. Okay? So these are reactants. This is your product. Okay. This is called your yield, and I probably should use different colors. So using the example of baking a cake, the yield is the baking time. Your cake's in the oven, you turn on your oven light, and you can see it rising. You can see it going from a liquid to a solid and a new substance, and that's the key word. New substance is formed with chemical reactions, right, or chemical equations, because this is a reaction. So moving on, when we calculate the atoms per element in chemical formulas, it's the exact same thing. It just looks different, okay? So don't get yourself worked up about it. Equations are simple. They're like formulas. First thing, just like we did, is we list, that is not good, you list your elements individually from both sides. And I like you to draw that line separating the reactants, your ingredients, from your product, okay? Now you're gonna count the atoms per element. So there is one carbon atom, two oxygen atoms, one carbon atom, two oxygen atoms, and that's it, okay? So you don't add them, that's the difference. Now, is this balanced? This one's easy to determine if this is balanced because, well, there's only two elements, right? But you have to do this. One carbon atom is on the reactant side, and one carbon atom is on the product side. That's good. Two oxygen atoms are on the reactant side, and two oxygen atoms are on the product side. That's good. That's balanced, okay? So let's go on to something a little more difficult. All right, the next one we're going to do is CH4 plus 2 O2 yields to, I think I wrote this big. I'm sorry, guys. I'm sorry. Be patient. Be patient with me. I'm used to that big old whiteboard, you know? CH4 plus 2O2 yields to CO2 plus 2H2O. All right, that's barely enough room. Draw that line down the middle. Okay, we're going to separate those reactants from our product. Okay, and if I'm moving too fast, make sure you pause this video so you can write this down and take notes. Okay, so next we're going to list all of our elements on both sides. All right, so we have carbon, hydrogen, and oxygen. We have carbon, oxygen, and hydrogen. Now we have another oxygen over here. You can list it separately or you can keep it together. It's up to you, okay? I'll probably list it separately just so it's It's more of a visual for some of us. Now, let's count our atoms per element. There's 1 carbon atom here. There are 4 hydrogen atoms right here. Now there's 2 oxygen atoms, but we also have a coefficient. So you multiply that. So 2 oxygen atoms times 2 is 4. So we're done with the reactant side. All right, let's go to the product side. 1 carbon atom, 2 oxygen atoms. We have that coefficient again. The coefficient times that subscript. Okay, so 2 hydrogen times 2 hydrogen is 4. Now we have that other oxygen. Okay, so there's 1 oxygen atom times the coefficient, right? Because it gets distributed, equals 2. So now as we are comparing the atoms on each side, we need to make sure, since we have this has to be combined, right? Just for the product side. So 2 oxygen plus 2, oxygen has a total of 4. So we need to keep that, we need to remember that. Okay, so there's 1 carbon atom on the reactant side, 1 carbon atom on the product side. We have 4 hydrogen atoms on the reactant side. We have 4 on the product side, 4 oxygen atoms on the reactant side, and we have 2 here plus 2 more, and oxygen checks out, okay? So that's balanced, that's good. Okay? We're gonna do 1 more, and then I will let you guys get back to work, and you don't have to hear me up here anymore, okay? All right. Last but not least, so we're going to have 4 H2O plus 3 CO2 yields 2 C4H8 plus 5O2. Okay, last one. We're going to draw that line, right? Just helps me organize things best. That's how I was taught way a long time ago. And I just think it's easy. So we're gonna list it, right? List those elements. H, O, C, and O. Again, you can keep the oxygen separate or combine them. It's really how you process information. Carbon, hydrogen, and oxygen. Okay? Let's start here. We have a coefficient. We have 4 molecules of water. Okay, so you're going to take that 4 and you're going to distribute that. So we have 2 atoms of hydrogen and 1 atom of oxygen. But we have this guy. So we have to get that multiplied. So 2 times 4, that's 8. 1 times that 4 is 4. This plus sign says, hey, stop. You don't need to distribute the 4 anymore. You're done. Right? So we're going to move on to the next compound in the equation, and that's going to be 3CO2. So that's 3 molecules of carbon dioxide. There's 1 atom of carbon dioxide times 3. 2 atoms of oxygen times 3, and that's 6. Okay? Moving on to the product side, 4 atoms of carbon, 8 atoms of hydrogen, 2 atoms of my markers, 2 atoms of oxygen times that coefficient. And that's 10. Okay, and then we're going to compare element to element. So 8 hydrogen atoms and 8 hydrogen atoms, that checks. 4 oxygen atoms plus 6 more, right? Because you have to combine the like elements. So 6 plus 4, that is 10. So that is 10. This is 10. That checks. 1 times 3. That is 3. That is 4. That doesn't check, right? So because these two do not check, the whole thing is unbalanced, okay? Now you don't have to balance them. Some of you might like that challenge and go ahead if you remember how, but I'm not going to get into the balancing part, okay? You just need to know that it takes one element to not have similar number of atoms and the whole thing's unbalanced. Again, reach out to me if you have any questions, please. I'm here for you. Again, I miss you guys so much. I've had a really hard time not seeing you and being with you. I have enjoyed my biological children, right? Because I call you my kids too, but I have enjoyed them, but I do miss you and I think about you all the time. So I hope this helped. I enjoyed it. I missed not teaching. So have a great day and let me know if you have any questions.